Why? What's up?
Because I need help in the lessons I missed in math in the modern world. Because I had severe dengue. Maybe if you're free, maybe you can help me.
Sure. The topics are quite easy lang naman. Where do we meet?
My house na lang if it's okay. I'm really sorry for the hassle.
Ano ba? No worries. I'm willing to help. Actually, I know a video that was made by L86 students and it's really effective.
Alright, see you. Thank you so much.
Okay, see you.
Come in. Hi. Thanks for coming.
Bye.
Okay, so where's the video? I want to see it now.
Wait, I'm gonna search for it.
Hey guys! Good morning, I am Jaime Valdecañas and I am with my group today. Today's vlog is about the application of math in the modern world. I will be talking about game theory.
I'll be vlogging about the mathematics as a language and for communication.
I'll be vlogging about mathematics for efficiency.
I'll be vlogging about consumer mathematics.
And I'll be vlogging about mathematics and nature and arts.
Okay, so let's start.
Hi, I'm Bea and today I'll be vlogging about arguments. So, what is an argument? An argument is a collection of propositions where it is claimed that one of the propositions, called the conclusion, follows from the other propositions, called the premises of the argument. So an argument is said to be valid if whenever all the premises are true, the conclusion is also true. Otherwise, the deductive argument is invalid. So here's an example. Consider the argument, all athletes are strong individuals. So look at this athlete. His name is Earl and he is an athlete. Therefore, Earl is strong. So is that argument valid? Okay, so the argument is said to be valid because the premises and conclusion are true. Thank you!
Hey guys, I'm back. And I'm with two of my friends right now. Introduce yourself.
Enzo! Mix!
For tonight's vlog, we're gonna be discussing game theory. So Enzo, what do you think is game theory?
Well, I think game theory, from what I know, game theory is when people use certain strategies when working with certain situations. Different strategies for different situations, basically.
How about you, Migs? What do you know about game theory?
I agree with everything he said.
So what Enzo gave us is exactly the definition of what game theory is from the course Math in the Modern World. It is the study of strategic interaction between participants or players in a situation or games that contains a set of rules and a set of outcomes. Okay, so we're gonna focus on the three different classifications under game theory. First, we'd start with simultaneous versus sequential.
Then perfect versus imperfect.
Then complete versus incomplete.
So let's start. Okay, to start off, we're going to discuss simultaneous versus sequential. So what actually is simultaneous? It basically means each player has only one move and all these moves are done simultaneously. And for sequential, no two players move at the same time and players may have several actions. Okay, and for the next classification, we have perfect versus imperfect. So what does it mean actually? A game is said to be perfect if each player, when making a decision, is perfectly informed of all the actions that have previously occurred. Otherwise, the game is called imperfect. And for the last classification for tonight's vlog, we have complete versus incomplete. In a game of complete information, the strategies, payoffs, and player information are common knowledge to all players. And on the other hand, the game is said to be of incomplete information. Some players may possess private information. As you can see, these two are now playing rock, papers, and scissors. This is a perfect example for a simultaneous game. Tic-tac-toe is a perfect example for both complete game and perfect game. These two are now playing Pasoy Dos, a known card game in the Philippines. This is a perfect example for a sequential game. So that's for tonight's vlog.
So consumer math is basically, it is where you use your basic mathematics skills when it comes to real life situations such as buying car, paying rent, going grocery shopping or shopping in general, paying taxes and stuff. So today that's what we're gonna do. I will be going grocery shopping and I will take you guys along with me. Hey guys, so we just finished buying groceries, and as you guys saw, there were a lot of people since it was on sale today. So usually people buy groceries or they go shopping when it's on sale, and they tend to buy more than what they need. So yeah, so I hope you guys enjoyed my vlog today. And yeah, thank you guys for watching.
Hey guys, so for today's vlog, I'll be going to Landmark and I'll be showing you guys how I'll get there by the use of Waze. So my mom's filming for me because, show yourself, mom. Hi. Because I can't drive while using my phone or filming. So I'll just type in where we'll go, which is Landmark here. It's 2.1 kilometers away and it will take about 12 minutes to get there. Waze is making us pass by Malugay. Turn left here. Then turn left in Malugay. And then just straight. Okay, Waze said we're gonna turn right in Bagtikan Street. Now we're here in Trina Rosas Avenue. And Waze said we're turning right in Talisay Street here. So we're very near here. We're near, it's like 3 minutes away, and with the help of Waze, we were able to go to Landmark using the shortest path. The Landmark's over here and Greenbelt's over there, and we'll be going here because my mom goes to the grocery here. I'll explain how Waze works with the help of graph theory. Hey guys, so right now I'm actually home and I just want to share how Waze and Google Maps actually work. The exact implementations for Google Maps and Waze are obviously proprietary, but we know that for their route finding algorithm, they're using some solution to the shortest path problem. Shortest path problem is a topic under graph theory, and since a map can be viewed as a graph data structure, the simplest solution would be something called Dijkstra's algorithm. If you can imagine traveling a long series of roads, you must make a decision which way to turn. Each time you reach a fork, exit, or intersection in a graph. In graph terms, it's node. So, in a typical graph data structure, each road or edge between nodes is labeled with the distance between the node and the next. So, the way Dijkstra's work is that each node, we choose the road with the least distance to the next node. We do this until we reach our destination. The sum of the least edges between nodes is the shortest route. So that's it. That's how I was able to go to Landmark in less than like 15 minutes with the help of the Waze using shortest path. And actually it takes me around 20 minutes without the help of Waze because it wouldn't guide me to the shortest route going there. So that's it. I hope you guys enjoyed. Thanks for watching.
Hi, I'm back. So today I'll be talking about the coding theory. So what is coding theory? It deals with the design of error-correcting codes for the reliable transmission of information across noisy channels. Data is usually transferred in the form of a series of zeros and ones. However, transmission of data is not perfect. And here's an example.
Hello, Bea.
Hello, Earl. Where are you?
Hello, Bea. Hello.
I think your signal is weak.
I can't hear you, it's choppy. Can you repeat what I said?
What are you saying? I can't hear you. It's choppy also. So that is the basic problem of the coding theory because messages are transmitted over a communication channel which is subject to noise, but noise can distort messages resulting in errors. That is why Bea and Earl's convo was messed up because of the signal and the noise around them. Thank you for watching.
Hi guys. Today I'll be discussing math in nature and arts. Hi. First math and art. Art is within math and likewise math is within art. The latter may seem hard to comprehend, but in further analyzing the connection between the two, one would be able to understand how it is actually possible. So, mathematics has always been influencing art in many ways. Mathematical concepts such as the golden ratio, the platonic solids, and projective geometry have been utilized by a number of great painters and sculptors. On the other hand, concepts such as the Pythagorean arithmetic perception of harmony has been influencing music until the present time. So technology has played an important role in building the connections between art and mathematics. So the first topic that can be correlated to math and art is the Fibonacci sequence. The Fibonacci sequence is one of the well-known formulas in mathematics. This sequence is named after Leonardo of Pisa, also known as Fibonacci. He discovered the numbers of the sequence as he was experimenting on how fast rabbits could breathe. Aside from being visible in artworks, the Fibonacci sequence can also be found in other things such as flowers and even music. So the next lesson that can be related to mathematics in art is the golden ratio. So the golden ratio is symbolized by the Greek letter phi. It is a special number in mathematics which is approximately equal to 1.618. It is commonly used in geometry, architecture, and other fields dealing with math. So the concept behind it is we find the golden ratio when we divide a line into two parts so that the long part divided by the short path is equal to the whole length divided by the long part. So next I'll be discussing math in nature. So math is evident in nature just as how it is present in art. It can be seen in the conventions and process of nature. So the first lesson under math in nature is the fractals. So fractals are considered as the most beautiful and at the same time the most bizarre geometric shapes that ever existed. The fun thing about fractals is that they all look similar in different scales. And when you take a piece of the shape, you would notice how it looks exactly the same with the entire shape. A fractal property calls self-similarity. So lastly, the three fractal properties are self-similarity, fractal dimension, and iterative formation. So self-similarity, basically, if geometric figures have the same shape, then these figures are similar. Self-similar objects appear the same under magnification. Second is fractal dimension. Geometry deals with objects with integer dimensions such as one-dimensional line and two-dimensional plane figures. Fractal, on the other hand, can have fractional dimensions like 1.262. Lastly, iterative formation. Fractals are formed by a process which is called iterative process. This is visible in all levels of fractal constructions. Thank you guys. Thanks for listening.
Hey
Hey guys,
Thanks for watching.